Ocean currents and climate. This image shows major surface currents in Earth's oceans. Surface currents, which affect water to a depth of several hundred meters, are driven mainly by winds. Large surface currents generally move in a circular pattern in Earth's ocean. Most of the currents flow east or west, then double back to complete a circle. But what is causing these circular patterns? Well, if Earth was standing still, then the currents and winds would flow in a straight line between the poles and the equator. But as Earth rotates, the passive winds and the currents curve in relation to the Earth's surface. The large circular systems of surface currents are called gyres. As shown, each current within each gyre moves in the same direction. However, if you look closely, you can see that the direction of current movement in a gyre is different in each hemisphere. Gyres in the northern hemisphere circle clockwise, while gyres in the southern hemisphere circle counterclockwise. So why do gyres move in different directions? Well, this is because of what is known as the Coriolis Effect. The Coriolis Effect is the movement of wind and water to the right or left that is caused by Earth's rotation. The Coriolis Effect causes fluids, such as air and water, to curve to the right in the northern hemisphere in a clockwise direction. In the southern hemisphere, the Coriolis Effect causes fluids to curve to the left in a counterclockwise direction. Now, aside from the surface currents you just learned about, deeper below the surface is another type of current that causes the chilly waters at the bottom of the ocean to creep slowly across the ocean floor. These currents are caused by differences in density rather than by surface winds. Deep ocean currents move and mix water around the world. They carry cold water from the poles back towards the equator and move very slowly. They may take as long as 1,000 years to make the round trip from the pole to the equator and back again. This flow of currents is extremely important because generally surface waters don't mix with deep ocean waters, but because of the polar regions where the surface water cools, it sinks and forms deep ocean currents, and this mixing causes what are known as upwellings. Upwellings are extremely important for the survival of some organisms because they bring up tiny ocean organisms, minerals, and other nutrients from the deeper layers of the water. The nutrients feed enormous schools of fish, and those schools of fish are part of the food chain for many other organisms in the ocean. So what do surface currents and climate have in common? Well, currents actually affect climate by moving cold and warm water around the globe. Climate is the pattern of temperature and precipitation typical of an area over a long period of time. So when currents carry warm water from the tropics towards the poles and bring cold water back down toward the equator, the surface currents warm or cool the air above it, and this is what influences the climates of the land near the coast. Now, example would be the coastal areas of the southern eastern United States. The Gulf Stream, for example, transfers a lot of thermal energy and moisture to the surrounding air. So as a result, the summer evenings in the areas around the Gulf Stream are very warm and very humid. Now, compare that to the current coming down the California coast. That is much cooler. Therefore, a summer evening along the California coast is often cooler and drier than a summer evening in Florida. Aside from gyres, there is another large system of ocean currents that affect weather and climate. This current system is called the Great Ocean Conveyor Belt, and it's illustrated here. The red indicates high salinity water which cools and then it will sink in the North Atlantic, and then the blue is deep water that returns to the surface in the Indian Pacific Oceans through the process of upwellings. As warm surface water travels from the equator towards the poles, it releases thermal energy to the atmosphere, which warms the surrounding region. And when the cold water sinks until there's an upwelling at different locations, this cycle will just continue to repeat. Scientists estimate that it takes about 1,000 years to complete a cycle. How amazing is that? Okay, it's time to stop here and show what you know.